discussing a presentation about MEMS, micro electromechanical systems, that can be used for sensing and compute. Really interesting presentation. I attended today here at Stanford by a professor from the University of Nebraska at Lincoln. This is very, very exciting stuff for me, because this is taking the compute paradigm really to the next level, literally to the next level. Like, you have this problem of von Neumann compute that has driven the whole digital revolution, and it's data in, CPU processing, back and forth with memory, and then something out. It's worked really well for many, many applications. But now that we're going into IoT and edge compute and robotics, we have different types of problems where the traditional digital compute stack doesn't really work that well. And this is where this presentation comes in. In a nutshell, we could have a sensor that could also be used for compute. I'm going to discuss this a little bit more in detail. I also want to discuss a paper. This is a paper discussion about humanoid robot learning. There's two key ideas here. The paper's in the show notes. Excuse me. One is 3D diffusion as part of the learning process. In other words, the computer sees a cabinet or a kitchen and then runs generative AI through diffusion to run scenarios that it could use to learn certain tasks. And the other part of the paper talks about egocentric teleoperated learning. So that just means that you use imitation learning, but you do it from an egocentric camera with an Apple Vision Pro that helps the teleoperator operate, and also helps calibrate the camera and all the input data that comes through the vision system. As a side note, I just want to mention the V-Robot event that I attended last week at Tesla. Just one thought that I thought is interesting is that I assume Tesla used the interaction with people, the massive interaction. There were, I think, about Ashok said something about the interaction with the robots in a tweet, thousands and thousands of interactions, which could be used for learning also, and I assume that's what Tesla did. So again, this is a paper about humanoid learning, and the V-Robot event is just a side note. This is not even a podcast. It's October 17, 2024. This is Krim Telco. It's the second installment of today. For the year, we're up 14.5%. The market is up 22.5%. We're underperforming by 8%. So let's talk about the presentation by a professor from the University of Nebraska at Lincoln. He talks about MEMS and how they could be used for low power, low cost edge compute, sensing and compute at the same time. In a nutshell, MEMS are mechanical devices. For example, they react when there's a certain movement. They react when there's a certain temperature or pressure change. So they're analog compute. So something changes in the physical environment, and then you have this physical movement of a device. And that physical movement could be used in combination with other physical movements to express, for example, a binary output, so a 0 or a 1, or even a sequence of zeros and ones. And you could use that, according to Boolean algebra, to express a gate, an AND or an AND gate. And lo and behold, we have a sensor that senses physical changes in the environment, that also, by sensing it, encodes gates. And once we have gates, we could develop algorithms. And lo and behold, we have compute that could be used to make decisions on the edge. So this is, in a nutshell, what this paper, what this presentation, and there's, by the way, there's a paper in the show notes also attached to it that discusses this in more detail. What I find very interesting here is that this could be used, for example, as a haptic sensing mechanism for robotics. This is this is something that we really care about here at Orange Capital Partners. But of course, it could be used for many other things. It could be also used for, let's say, airbags in cars, or it could be used for gas detection in kitchens and so on and so forth. So there's a lot of applications for physical sensing mechanisms that could be used in conjunction with compute. I think this is the key. And just as a general thought, we attend these presentations here at Stanford on a regular basis, and it's really interesting how people come up with new ideas and new concepts to solve problems. And the fundamental problem with edge compute is the problem of low power and low cost on the edge, and I think this is a really elegant solution. The next thing I want to discuss is a paper. It's about humanoid robot learning. The paper is out of CMU, I believe, a couple of other universities. It's in the show notes. Now, this paper brings two interesting ideas to bear. One is the concept of diffusion as part of the learning process. So let's say you have sparse information. So what that means is, let's say you see a kitchen and you see a bunch of stuff on that kitchen, and you could now use generative AI to use the images that you have and extrapolate a couple of scenarios that are possible given what you see. So this will be the diffusion process. And the other idea is the egocentric camera-based, vision-based learning process in conjunction with teleoperation. That is literally, imagine a robot being teleoperated and has egocentric vision and uses that input to learn, let's say, how to behave. So this is the fundamental idea. The details are in the paper. I think for us here, what's interesting, of course, we're heavily invested in the humanoid robot space through Tesla. We attended the V-Robot event recently, and there they were obviously teleoperated. At least that's the speculation. I actually asked one of the robots whether it's teleoperated or not, and the answer was, I am not fully autonomous, but soon I will be. So let's, you interpret that any which way you want. But in my opinion, this means they were teleoperated. What the authors in the paper mention is also using an Apple Vision Pro for teleoperation. I don't know exactly how that works technically. I can only imagine how it actually manifests itself. So you have this Vision Pro and you move around, and while you're moving around, you're also moving the robot. So you're kind of imagining to be the robot, and you can act, and then the robot can learn from those movements. And it's possible that Tesla actually used an Apple Vision Pro type virtual reality setup to move the robots around at the V-Robot event. So to summarize, two discussions here. One is a presentation using MEMS for low power, low cost edge compute and sensing in one. And the other is humanoid robot learning, incorporating incorporating diffusion, three-dimensional diffusion as an data enhancement, synthetic data generation for robot learning, and then imitation learning through egocentric cameras and teleoperation via Apple Vision Pro. Now, it doesn't have to be Apple Vision Pro, but I think it's a neat idea. It's an elegant approach towards teleoperated imitation learning for robots. Thank you.